Imagine a chain reaction in space. One collision triggers another, then another, and another. Soon, a debris cloud engulfs Earth. This is not science fiction. This is the looming threat of Kessler Syndrome.
Named after NASA scientist Donald Kessler, Kessler Syndrome describes a scenario where space debris density reaches a critical point. At this point, collisions become inevitable. Each collision creates more debris, further increasing the likelihood of future collisions.
This chain reaction could make space exploration impossible. It could also disrupt vital satellite services we rely on every day. Understanding Kessler Syndrome is crucial to comprehending the urgency of the space debris problem. We must act now to avert this potential disaster. Every satellite launch, every rocket stage left adrift, adds to the growing junkyard in Earth's orbit. This debris, ranging from defunct satellites to tiny paint chips, travels at incredibly high speeds. Even a small piece can cause significant damage upon impact.
The past saw fewer launches, mostly by government agencies. Today, commercial space ventures are booming. While this signifies progress, it also means more launches and more debris. Adding to the problem, some satellites are not designed for deorbiting after their operational life. This leaves them as potential hazards, increasing collision risks.
We must prioritize sustainable space practices. We need to manage the debris we create. The threat of Kessler Syndrome is not theoretical. It is a very real and present danger that could have catastrophic consequences for our space activities. We have witnessed the destructive power of space collisions firsthand, and the aftermath is often devastating. In 2009, a defunct Russian satellite collided with an operational Iridium communications satellite, creating a massive debris field. This event created thousands of pieces of debris, each one a potential threat to other satellites and spacecraft, highlighting the real danger of space collisions.
Even small debris traveling at high speeds can cause significant damage to spacecraft and satellites. In 1983, a tiny paint chip, traveling at high speed, chipped the windshield of the Space Shuttle Challenger, demonstrating the potential for even the smallest objects to cause harm. These incidents underscore the vulnerability of spacecraft, even to seemingly insignificant objects, and the need for robust protective measures.
These events serve as stark reminders of the potential consequences of inaction. If we do not address the issue of space debris, the situation will only worsen. Each collision increases the risk of future collisions, creating a dangerous cycle that could make certain orbits unusable. This pushes us closer to a cascade effect, where the density of debris in orbit could lead to a chain reaction of collisions. We must learn from these incidents and implement measures to prevent future collisions, ensuring the safety and sustainability of our space endeavors. Section 4. A world without space. The dire consequences of inaction. The consequences of inaction go beyond the loss of satellites. Imagine a world without GPS, weather forecasting, or global communication. Kessler Syndrome could cripple these essential services, disrupting our daily lives.
Scientific research relies heavily on space-based instruments. Kessler Syndrome threatens astronomical observations, Earth monitoring, and scientific advancements.
The economic impact would be immense. The loss of satellite services would disrupt global communication, finance, and transportation systems.
Furthermore, the debris field could create a barrier, trapping us on Earth and hindering future space exploration. We must recognize the far-reaching implications of this issue and act before it's too late.
Section 5. Cleaning up our current efforts and future innovations. In this section, we delve into the ongoing efforts and future innovations aimed at tackling the growing problem of space debris. The good news is, we are not powerless against this threat. Various initiatives and missions are already in place to address the issue. Scientists and engineers are developing innovative solutions for space debris mitigation. These efforts are crucial for ensuring the sustainability of our space activities.
These include removing existing debris using advanced technologies and preventing the creation of new debris through better design and operational practices. Several concepts are being explored, such as space-based lasers to nudge debris out of orbit, which could significantly reduce the risk of collisions. Robotic arms to capture and deorbit defunct satellites are also being tested, offering a hands-on approach to debris removal, and even giant nets to collect smaller debris, which can then be safely deorbited.
Furthermore, there are ongoing efforts to improve satellite design. This includes making them more durable to withstand small impacts from debris. And ensuring they can avoid debris through advanced maneuvering capabilities, and equipping them with propulsion systems for controlled deorbiting at the end of their operational life, ensuring they do not contribute to the debris problem.
These technological advancements offer a beacon of hope. But technology alone is not enough. We must also focus on policy and international regulations. We need collaboration and international cooperation. Only by working together can we ensure the long-term sustainability of space activities and protect our shared space environment.
Section 6. A united front for space. The need for global cooperation. Space debris is not a problem for one nation. It is a global challenge that requires a global solution.
International cooperation is crucial for establishing and enforcing responsible space traffic management practices. Agreements need to be reached on debris mitigation guidelines, such as mandatory end-of-life disposal plans for satellites and responsible launch practices to minimize debris creation.
Data sharing is crucial. Tracking space debris is a collaborative effort. Sharing data on debris location and trajectory is essential for collision avoidance and debris mitigation efforts.
This is not just about protecting our satellites, it's about preserving space for future generations.
Section 7. Safeguarding our future among the stars, a call to action.
The future of space exploration, and indeed our future on Earth, depends on our actions today. Every decision we make now will shape the destiny of generations to come. We must act responsibly and collaboratively to address the growing threat of Kessler Syndrome, which could render space activities impossible. We must support research and development of space debris mitigation technologies. Investing in these innovations is crucial for maintaining a safe space environment. We must advocate for responsible space policies and international cooperation. Only through united efforts can we ensure the sustainability of our space endeavors. We must raise awareness about this issue and inspire others to join the effort. Public engagement and education are key to fostering a culture of responsibility. The stars have always beckoned humanity, offering a canvas for exploration and discovery. They remind us of our potential and the endless possibilities that lie ahead. It is our duty to ensure that future generations inherit a pristine and sustainable space environment. We owe it to them to preserve the wonders of the cosmos. Let's work together to keep the space frontier open for exploration, innovation, and wonder for generations to come. Our collective efforts today will pave the way for a brighter tomorrow.